So this week we're going to work on truth tables, but before we do that, and we're going to do binary addition and subtraction. Before we do that, I want to talk a little bit about the inside of the computer. So we've talked about the RAM, or the computer's memory, and all it is a long list of memory spaces that have an address of 0 all the way up to whatever it could be. Let's say 4 gig. If we have 4 gigabytes in our computer. So the number goes from that, each one is numbered. Now the size of that, called the byte of the computer, can be anywhere from 8 to 64 bits. 8 are old-fashioned computers. The modern microcomputers that we work with, ones on your desktop, whatever, are using 64 bits. Now, if we want to move something, say from location 101 to location 10010, what we need to do is we need to have something that can connect these two together. And that's called a bus. And we have what's called a data bus. Now the data bus connects every piece of memory to all the other pieces of memory. So each one is connected to the data bus. So it's a lot like the Ethernet network, where we can only do one at a time. So every piece of memory reads or listens to the data bus at the same time. But whether they read or write depends on whether their address comes up. And so what we need is an address bus. And the address bus connects to each one of the pieces of memory as well. So what you need to do is you need to put an address on the address bus, and then that will tell that piece of memory that the data is for you, or you're supposed to put the data on the bus. Now, how does it know whether it wants to read from the bus or write from the data bus? We have the third bus, which is the control bus. Now, everything in the computer is digital. Everything is in the memory. So where do these numbers come from for the address bus? Well, they're just another piece of memory. So what we're really doing is we're saying, if we want to move from here to here, we put this address on the address bus. We tell it to write from the control bus. This copies onto the data bus. Then we put this address on the address bus, and the control bus says, write, and it writes it from the address bus back into that. So we move from one to the other. Now in reality, there's a whole lot more going on, because the address is one piece of memory here. So if we have a 64-bit, the address bus should be 64 bits long. But it really isn't, because 64 bits is a huge amount of RAM, much more than we're ever going to use, quoting Bill Gates. And so we end up having cutting down on the size of the address bus less than the memory size. Now in the olden days, when I was young, we had 8-bit memory. And 8-bit only gets us to 256 bits of memory, 255. So what we need is a bigger address bus. So we use 2 pieces of memory to use a 16-bit address bus. So the byte size is the size of your memory, and the data bus has to be the same size as your memory, but the address bus can be bigger than your byte size or smaller than your byte size. In the olden days, the address bus was bigger than your byte size. In the modern world, the address bus is shorter than your byte size. And of course, the control bus is just a very small bus, because it just says whether to read or write. And that is the bus structure of the computer. The important thing to remember is everything is just a single 64-bit binary number on this long stream of memory. That's it. The whole computer is just binary numbers.